want to welcome everybody. Thanks for taking time out of your evening or your morning, depending on where you're from, to join us here tonight. Tonight we have Sarah Schaefer. Sarah is the principal at Methodology, and their mission is to teach teachers new and better and exciting ways and to inspire and nurture creative forces that lie within each of us. Sarah's been teaching K-12 mathematics since 1995. She has developed a curriculum of her own. She is the go-to person when you talk about the Singapore methodology, and she just thrives in helping students, teachers, and parents, helping us all make those connections between why things work and how they work. So with that, I am going to turn it all over to you, Sarah, and Ryan and I will monitor the chat. So take it away, Sarah.
Excellent. Thanks for that. And thanks to all the guys at Brainingcamp for making this happen. I have been pretty passionate about Brainingcamp since Dr. Yup Bonhar and I kind of crossed paths in 2012 or 13, I think it was. And ever since, I am a firm believer in it. So with that, I just want to thank you guys for having me. I just put in the chat a Google Doc that will have all the information that I'm presenting tonight. So if you want to grab that Google Doc, you can make a copy of it, and then I'll share copies at the end as well. Make sure that you've downloaded this code, because in my trainings, you will be active participants. There's nothing worse than to just sit and listen for 1 hour. So I really want you to become involved as much or as little as you would like to. So I'm going to get started today. We're really going to look at this idea of CPA. We use this term. Some people say CRA. The idea isn't new. It's Jerome Bruner's idea that we learn best when we can connect ideas. And we are born with visual brains. And how can we connect the picture and the abstract representation? And Richard Skemp talks about that relational understanding that between instrumental and conventional ways of doing stuff. So that's my goal for us tonight. We're going to work through, or this morning for some of you, we're going to work through a few tasks and using the virtual manipulative, really see how students can learn some pretty tough concepts. Will you get on axis? Yes. Okay, so my name's Sarah. I'm from Florida, and you'll learn a little bit about me as we go through this presentation, and feel free to ask questions. Some people asked if the recording would be available afterwards. It will be by going to the Brainingcamp page, and up top, if you click on that webinars button, you'll be able to get the full webinar there.
Before you get started, I'm sorry to interrupt you. The other thing that people are saying is the link that you provided for your document.
Yes.
Saying that we need access.
Oh, all right. Well, give me 1 second and let me just
stop you now instead of at the end.
Absolutely.
And we can repost that for you.
Okay. So I want you, as I'm doing this and I'm getting this document for you, I want you to think about what your struggles are in a virtual environment, because they all bring different struggles for us. So when we think about a virtual environment, we've all had to kind of live in it. Let me get this link 1 second here. Okay. All righty. I'll put it in the chat there now, and we should be good to go. All right. And if not, I'll just share the PDF at the end if that's an issue. You don't need it to get started, but it will be helpful to refer back to. So the challenges I want to speak to tonight are in this idea of CPA, and for some people, they're not quite sure what that might stand for or represent. We're going to talk about the C being that concrete experience, the P being the pictorial experience, and the A being the abstract. So in our top left corner, ideally, we would want kids in front of us. But in a virtual environment, we haven't had that opportunity. So what kinds of concepts can be taught virtually? So we really need to think about the concept and what the manipulative offers. So for example, we have some kindergarten kids right now that are working on geometry. Geometry is not something with my kindergarten kids who are feeling and that sensorial where they're bringing their own language to it that a virtual manipulative for me would work initially. So we really got to think about the concept. And when we have that concept, how the manipulative is going to take us to the abstract or that conceptual understanding. So today we're going to do some tasks to see that. The other thing I struggle with and teachers I work with struggle with in a virtual environment is how do we collaborate? So we get these ideas, we use these manipulatives, and we know that we learn best in collaborative environments. So what kinds of things could we do with these manipulatives to collaborate? And last but not least, one of Richard Dufour's, you've heard of his key 4 questions, key questions, and one of it is, how do we know the students have learned it? So in a virtual environment, how can the manipulative help to show that there's complete understanding? So today or tonight, our tasks are going to do just that. The first task we're going to do comes from kindergarten, and I'd like you to go ahead and copy this code. It's on that handout, or you can just type it in. You're going to want to go to your Brainingcamp page and sign in. And when you go to your Brainingcamp page, there's a share code. So I'll just bring that up here. This share code down in the bottom, the center at the bottom, you can go ahead and enter this code in there. And when you enter that code in there, we should come to a page with 6 square tiles. And tonight, our task is for our kindergarten students, how many shapes can you create with 6 square tiles? So I want you to go ahead and grab those 6 tiles. And when you're grabbing on them, if you're not used to these manipulatives, you can just go ahead and click on it and continue to click until you get 6. Your choice if you want to use different colors. But here is one rule that we need to make sure that we know. When we're putting our shapes together, this here is a legal move where I can put in one whole side is next to each other. I cannot combine and make a shape with the corners touching. So I want to give you about 2-3 minutes maybe. How many different shapes can you make? And then if you were on the telephone, how would you describe your shape to a friend? All right, and if you have some ideas on how you might describe it, since we can't hear you, go ahead and put it in the chat. How might you describe your shape? Yeah, a lot of kindergarten kids talk about it looks like a letter. It might look like a shape. Could you use numbers to describe your shapes? All right, like a letter U. So I'm going to start with that idea of a letter U. Can you imagine a letter U and what that might look like? I'm not sure if I've got a U, maybe like you thought, or maybe it's a little longer. In looking at this U that we have, is there a way that we could describe this U with numbers? What do you see? Oh, your friend says they see 2 and 3. So 6 is made of 2 and 3. Can you imagine where your friend is looking? If 6 is made of 2 and 3 more. Is there another way to describe 6 looking at this? 2, 1, 1, and 2. 2 and 4. Can you see, whoops, 2 and 3 there, that wouldn't work. Sorry, 2 and 4, thank you for that. Oh, somebody sees 4 and 2 more. What if we took and we rearranged it like this? How might we see 6 now? Or now? And so could we mathematically, if we see 6 this way, we can see 6 as 3 and 3 more. Can we now write a math sentence from that, from this number bond? We can see 3 and 3 make 6. And so we're decomposing 6 into its parts. And so part of the kindergarten standards talks about the idea of taking a number and through the idea of visualization, can you imagine? What do you see? How can we record this? And so when we can see 6 in all these different ways, students start to say, well, 2 and 4 could be the same as 3 and 3. And what other ways could we play with 6 square tiles? And so students will take their ideas from maybe from their Brainingcamp, because they can take pictures, and in a Google slide, here's an image of some kids that were working together. They took a picture right there in the Brainingcamp app, and they shared 6 and showed how many ways. Another student thought it was her clever day, and she showed 6 in another way. And then it brought a conversation about 6 could be 3 parts, and how might we write that both in words and in symbols? Again, another student, they saw 6 and 0, and they thought it was really clever to use the colors to show the different ones. And sometimes we have students that will choose not to use the manipulative, but they just notice that there's a pattern going on. So in this little Google slide, it's easy for students, if we share the Google slide, they can just cut and paste. They can copy it right from the Brainingcamp screen. And then another way that I like to have kids sharing and doing it is even a Jamboard. So you might have students that will copy and just paste it in their Jamboard, and then we can create that collaborative environment through the use of the Brainingcamp app. So the goal here was, how can we take a visual childlike representation, add some childlike number bond conventions, and then transfer that to the equation used. So I really like Brainingcamp for sharing. The kids don't share in the moment in Brainingcamp, but they will, if we go back to our Brainingcamp and you go over to the left-hand side, you should see a share. So right now, if I click on this share button, I have a choice to take a copy, download the image, or send my teacher the link. I like the copy, and then I'll just jump over to my Jamboard. And if I'm on this Jamboard, I can just paste it right there, and there we go. It's very clean and it's very simple to use. So the students, the collaborative part of it would be done outside of Brainingcamp, but the flexibility to be able to take a screenshot there is unmatched. The other thing we can do is we can enter some of these. What I've done with Brainingcamp is I've entered some into, if we want to make sure that students can really understand it and how do we assess them, I might take it into maybe a Seesaw or an app where I can record some voice, and I'll again walk them through how to do the Brainingcamp. The links will be right in there. It will take them to their Brainingcamp, and then they can add voice to it, because we know that voice is a really powerful thing to add. So we started with the Brainingcamp idea, and then we want to, in a virtual environment, learn how to collaborate with our models to generate some discussion, and then also how can we assess. And so a favorite platform of mine for that is that Seesaw app. So first task here, pretty basic kindergarten. When we talk about that CPA approach, tiles aren't something I feel for this activity needed to be in their hands. There was going to be no advantage of the actual tile versus the virtual manipulative. So I, as a teacher, need to really be cognizant of how I'm recording it, so that the methods, as Richard Skemp says, here's our conventional way of recording it, and how does the picture link up? And so use of color, we might be able to show it, but also by having those representations right next to each other, it kind of tells a story for that student. Any questions or anything quickly that you want to ask, or what anything you noticed or you wonder about the first quick little kindergarten task? The goal was, if we are looking at standards, the goal here was that it's a kindergarten standard that we could decompose numbers within 10 in multiple ways. That visual representation allows students to see it. All right, next task. Here we go. We're pulling the next task from Think Mathematics. Grab your base 10 blocks and go ahead. If you'd like, you can enter this code and it will take us there. Your next task is, our friend Min Ho here is asking us to show 72 cubes using base 10 blocks. And I'm wondering, how many different ways could you use them? And then could you use a number bond or an equation like he's recommending? Richard Skemp is a researcher, a British researcher. And I want you to think, as teachers, as you're building this in a virtual environment, your board is telling a story. How do you want to write things? How is color going to help the students connect the ideas? For those of you new to Brainingcamp, if you can again just click on the block and continue to click to get your 72. In our classrooms, you must have at least 2 different ways to build 72. And if it's your clever day, maybe you have 3 ways. And how are you going to record that? Think of color. Is color important? All righty. Do we have at least 1 way? 2 ways. Can anyone share in the chat another way? I've showed 70 and 2, and I can represent it in a number bond, and I can represent it with a math expression. 70 and 2 more, and it matches my picture. 60 and 12, can you imagine? We're building the visualization. Every time I say, can you imagine? I'm trying to get the kids to hold the picture in their head, and then I'm going to show it. So your friend is saying 60 and 12. Can you imagine what your friend had to do to get 60 and 12? Is this what you thought? Oh, and I like the little eye marker at the bottom. The kids will open it up to just make sure. That's still 72. So how are we going to represent this 72? We have 60 and 12. And then we had another friend that said, oh, 50. I think you're onto something. Are you noticing any patterns? Yes, so students will start to build, and isn't that what mathematics is about? It's about solving it and looking for patterns. So we have 60 and 12, and then as we decrease by 10 there, we increase our ones by 10. And can you see what would come next? Could you prove it? So your friend is saying, I think it might be 40. So if I bring this over here and I do 40, and how many is this? That's right, 32. I have 3 10s and 2 more. So early on in first grade, this app has been a lifesaver to me. How many times do you have the base 10 blocks just falling everywhere? And it takes 10 minutes for them to actually count out 10 and put it back in. And yes, there's a time and a place. But when it's 72 and I have a bigger number, this app is beautiful. The ability to take apart and put it back together just in that moment and then check ourselves is invaluable. So in doing this, notice we're starting to build what I want to think about as number sense. So if we think about this CPA approach, we have a representation, a pictorial representation here. If kids had their actual base 10 blocks, yes, they could use them. But again, I think at this point in the game, we're not worrying about just the simple exchanges. We visually are supporting that. Our goal is now to transition to the different ways we're going to decompose this number. So initially, before we get to the operations, we're working on this idea of decomposition, because we know that eventually we're going to have to take this, and let me just pull up, come back here, and we're going to have to decompose and make sense of a convention. And so when kids are decomposing without the busyness of the actual addition or subtraction, then we can focus on what's going on. So concrete experience in a virtual environment, unless you've sent home these base 10 blocks, cannot happen with this task. So we then say, okay, how can we get that pictorial? The goal is to link the pictorial to the abstract, right? Because we soon will have to do something. So we're building this flexible thinking with students, and they're saying, oh yeah, 72, 70 and 2. Oh, it could be 60 and 12. It could be 50 and 22. Well, what do I want it to be? I don't know what I want it to be until you give me the problem, because some problems are going to require one way of decomposing the number, and another might require another one. So I want us to think about grade 2 subtraction. We know that subtraction is a really hard thing for second grade teachers. I always say to my teachers, when you get to this chapter with renaming, if you drink wine, then go get yourself a case of wine, because you're going to want to go home and have some wine. Can you not see my screen? I'm seeing. Can somebody give me a thumbs up if you see a grade 2 subtraction?
Yep, we can see it.
Okay, all right. I'm just looking in the chat there. I want to make sure. So when we started tonight, we said in a virtual environment, it's really important to assess, do they really know what they're doing? And so I've seen a lot of people sending home worksheets, and the kids will fill in worksheets because that's what they have access to, and they will then grade the worksheet. But I want you to listen into this little student that I was working with a few years back now, and think about if she handed in this problem, it's done correctly. But I want you just to listen, and then what do you notice and what do you wonder?
Six minus 27 equals, you can't do that. You can't do that. And then, but 2 minus nothing. Well, this is the only number that you could extract. So 2, and then that turns into 1. And then you turn this, and then you turn it into 9. And then you make this 16.
So why did you have to do that?
Because we didn't have enough, because 6 is a smaller number. 0 is a smaller number than 2, but 2 has nothing, so it can go, you can make it a line and so make it a 1.
So when you cross all that out, you have a 1, you have, what else do you have there?
I have a 1, I have a 9, and I have a 16.
And what number is that? 1, 9, 16.
190, wait, 1,916.
Type in the chat. What do you notice? What do you wonder? Yeah. This was a student that I was supposed to be watching for the gifted group. Her mom had brought her because she was gifted. And so many second grade classrooms I go into, when I ask the students, it looked like you did a lot of crossing out there. What number were you making? And they'll say exactly what she did. But if we collected this worksheet right now, we would give her a check. Yep, she got it right because she can follow the steps. So the Brainingcamp app, and through the voice that we're gaining, we're seeing that, does she really have place value? Does she have conceptual understanding for the process of subtraction? So I love, love, love. In the Think Math series, you can see here when we talk about the CPA, you can see the concrete that we were just working with in the Brainingcamps, and then the ability to decompose and right next to it show that conventional algorithm. So when we go back to our Brainingcamp app, these 3 elements have to be next to each other. We have to be able to see the pictorial representation, what that means in regards to what we're doing. We'll show that childlike number bond, and then we're going to go to the convention or that algorithm that we want them to understand. So I want to practice this idea with your Brainingcamp. And we're going to do 72 now again, but this time I just want you to grab your place value discs, because now we're going to be doing some division and multiplication as well. And so if you want to grab that code, I think Mark or Ryan have been helping me out and putting that code in the chat. And when we build 72, I want you to think about the different scenarios. So the very first way was typically 70 and 2. And how will your way change if you're subtracting 21? What is the best way to decompose it? Could you show it on your Brainingcamp app? What are you going to do? Is 70 and 2 a good choice? If it is, then leave it there. Now, as a teacher, how are we going to record it? 72 so that it makes sense. Remember, our end goal, as some kids will say, is the stacking method, right? Not really. It is a method, but they have to understand these conventions. So when we take the 70 and the 2, is it friendly to subtract? And I really hesitated when she said in that video, you can't do this, because, you know, once she gets to negatives, yes, you can do that. And so I'm really careful with the language that I'm using. So is it going to be friendly to subtract that 20 from those? And then is it going to be friendly to subtract those two, that single 1 from the ones? And if it's good, then you know what? Then this is a good choice. But what if it wasn't minus 21? What if it was minus 28? Now what does your app look like? Think about, as teachers, how are you going to now record that? So when we look here and we're trying now to subtract 28, we might have some issues here, right? Can we do it? Absolutely. Our government knows a lot about spending money we don't have. It's called you're in debt. But in 2nd or 3rd grade, we might not know that. So what is it that we're doing? We are renaming. And so we can take one of these 10s, and how are we going to is that still 72? Yep, I can see it right there. And now, how does that look when I record it? So now it became 60 and 12. Does your picture or your model show that? Will it be easy to subtract 8 from these ones? Will it be easy to subtract 2 10s? And then the final stage is what we call the abstract, or the conventional method here is how do we record it here? So I want to hear kids say that is 60 and 12. Well, why wasn't it 70 and 2? Because for this problem, that wasn't the friendliest way for me. Some other students might have broken it into other ways. Maybe they broke 72, and I'll just put it over here, and they had to subtract 28. Can you imagine why they might break 72 into 30 and 42? Can you imagine where they would take the 28 from? Now we're getting a little bit more of some reasoning strategies versus the conventional base 10 strategies, but students will kind of talk their way through this. I want you to go back to that 72. And now, how are you going to think about 72 if you divided it by 2? What do you want to think of it as? Oh, 60 and 12. Is 60 friendly to divide by 2? Is 12 friendly to divide by 2? So if that's friendly, then that's a good way. 72 divided by 3. Now, how do you want to think of it? Do you still want it 60 and 12? Yeah, I see people saying, yes, I want. So this idea of having a visual model there, then the kids start to just see it. And they don't act, we're pulling that manipulative away from them when they're ready to see it. So 72 divided by 4, 72 divided by 6, 72 times 6. So what is number sense? Number sense is knowing how to decompose the number when you give me a problem. So the first task we did was more of 1st grade, just play with 72 and let's get equivalents. Now we need to start doing something with 72. So the visual model here and the ability to put it together and take it apart, and then right next to it, to put that childlike number bond, and that conventional method is going to be key. So if we go back here, as we're having kids in modeling, they're going to model the way that we model. So we want to take that picture, we want to link that childlike way to that conventional way. This in essence is the CPA approach. Why are students doing what they are doing? And can they explain it? Unlike our little friend here that could use the conventional method to get a right answer, but that the conceptual understanding was not there. All right, so other questions you might have before I jump in? I'm going to move us through. I have 2 more tasks. I want to show the beauty of the manipulative and how it can support you in a virtual environment to get that conceptual understanding. Base 10 versus DISC. The program that I'm working with right now, Think Mathematics, we transition in 3rd grade with some things and then into 4th grade. I use the base 10 blocks, especially when the kids need to see one-to-one correspondence. So I would never use the discs in 1st grade ever, but some programs will introduce the place value discs in 2nd grade and take away the base 10 blocks. But I usually do it in 3rd grade. The reason why our students can't connect ideas is because the way we're modeling it. We can't teach concrete one day. Then the next day we do number bonds. Then the next day we do the conventional algorithm. They really need to see this connection. And we're just switching each day the type of problems that they're doing. All right, so we went through, we got some addition, subtraction. Number sense for me is the ability to decompose numbers. How do we develop number sense? We need a visual model. We need the base 10 blocks. We need them. They have to see them coming apart, coming back together, and then separating them and recording them. The visual support is critical. All right. Now I would like you to jump to the pattern blocks. Pattern blocks. The other thing with base 10 blocks versus place value disc, if you are actually in person and you're using the physical manipulative, again, I like the virtual because there's no sensorial aspect to holding the discs or seeing the disc that is going to affect the understanding. For me, the discs and base 10 blocks virtually are my go-to, even if I am in person. But think about how many base 10 blocks you need if you're trying to decompose 72 in all different ways. You have kids that are trying to make collections on their desks, they're falling off. And so it's just an easier way to organize. Even in Seesaw and some of the other apps where you try to bring in pictures, it's just not as clean as the Brainingcamp app. I also use connecting cubes in Brainingcamp all the time. Yep, in kindergarten. All right, so here's our task. If you clicked on the code, Mark, I think, described me perfectly in the beginning in that I want you to understand why you're doing what you're doing. And if you didn't get that through the subtraction piece, you're going to get it now in this fractional piece. So find your pattern blocks, grab that yellow hexagon, and we're going to define this hexagon as 1. And if this is 1, then we could use our blue piece to show 2/3 as shown in my picture here. I want to give you a few minutes. How could you now show what 1/4 of 2/3 is? 1/4 of 2/3. We have some friends that are saying, look at the green shape. I wonder why they're looking at the green shape. Again, if you're new to Brainingcamp, you can kind of highlight it and you could duplicate the shape. So you could just bring it down. You don't have to redo. I'm wondering why our friends are saying the green. Can you imagine? Some of the some of the manipulatives, and correct me if I'm wrong, Ryan or Mark, you can change the colors for, but this one doesn't seem like you can change the color for it because pattern blocks are kind of this color, the actual ones and these.
That's correct. Color tiles, you can toggle through the different colors.
Yeah.
But not on pattern blocks.
All right. So what is the solution here? So 1/4 of 2/3 you're telling me is the green shape. And what is the green shape? How would we name that green shape? 1/4 of 2/3. So we have a pictorial representation. We have this visual model that Jerome Bruner was saying is so critical, right? We can manipulate it, rotate it a little bit, fit it in here. Maybe rotate it a little too much. There we go. And then I could duplicate that, bring it here, and then duplicate that, rotate it and fit it in. Can you see what 1/4 of that 2/3 is? And your friend is saying, of course, because here's my 2/3. So this is 1/4 of it. And how do we name that piece? Fractions, numerator. Numerator is a cardinal number. It's a number. How many? It answers how many. We have 1. Denominator is not a number. It looks like a number. It actually is. It's a nominal number, though. It's a name. This shape is called what? This shape is called a 6 because 6 make up 1. That's the name of this shape. So a lot of times we'll spell out the word 6. So here's my question for you. We can all see this visual idea, but if you went to the same school I went to, I had a teacher that taught me this. Sarah, go ahead and cross cancel first because it will simplify things. And then just multiply across. So why does it work? Why do we do things like this? So can you, with your pattern block, show me what are we actually doing or saying when we do this cross-canceling method? So what is that saying? I'm sure you had the students of, I don't know, maybe you even teach this. And I'll tell my teachers, don't teach it unless you can explain why. Yes, it's going to give them the answer. But you know what? This thing right here that doesn't have a brain can also give me the answer. Yes, they're simplifying, but why does it work? Just saying divide by 2, we get that. I want us to think about math as a language. And if math is a language, how would we read this expression? What is this new expression saying? how do we read the math? If this is 1/4 of 2/3, then what is this? That's right, Maria, thanks for that. 1/2 of a third. Could you show me what 1/2 of a third looks like? What is 1/2 of a third? Oh, it's also a green triangle. Isn't that crazy that now we can write an equivalent statement that 1/4 of 2/3, 1/4 of 2/3 is the same as saying 1/2 of a third? And could you now prove that visually with the blocks? Is it easy for a student to see that yes, it's simplified, it's a simpler way of saying. So if you can't see it, let's go ahead and look at it. This piece right here, we agree is one piece. And if this is the whole, we call this 6. But what does 1/2 of a third look like? Well, we said here's a third, and isn't 1/2 of the third the same? Is there another way that you could describe that amount? So visualizing it, we can see 1/4 of 2/3, which is this, is the same as 1/2 of this 1/3. Here's that 1/3 here. And we can see that that is the same way of talking about that red section here. So I wanted to make sure that you got a few different grade levels and seeing this idea of CPA, CRA. Again, the goal is, how do we support what we're doing in the conventional or abstract with a visual representation? We have visual brains. We need to really come and tap into those visual brains by providing that picture. So one thing we want to really think about is, what kinds of things are we doing with tasks? So I want to look at this task at the bottom of the page here and take a minute, and what do you notice about the way that the task is given? Yep, the task is small. There's a visual. What is the task asking the student to do? Yeah, it's not asking. Too often we give a task and say, what's the answer? But I love this because it's building the metacognition. To solve this problem, I don't want to know the answer initially. I want to know the best way to think about 400. And could you show it in a number bond? And then how might that transfer to the equation? So could you grab your blocks and could you think about and visually see, is it going to be friendly to take away that 100, that 80, and that 7 from the way that you visualized it? You have the virtual manipulative there. And then as the CPA approach goes, now let's link that to that abstract representation. So that's the same thing we saw in this 4th grade or 5th grade task here. I like pattern blocks for this. Choice of numbers is key. Not always will these pattern blocks work if I change the choice of number. But if I'm trying to just have them see equivalent expressions, which was the goal for me here, that cross-canceling and why it works, we're going to want to make sure that we tap into our number choice. So I'm looking at the clock. We have about 10 minutes left, and I want to take some questions that you might have on anything that I used or presented.
Hey, Sarah, this is Mark. I did see one question earlier on, and I was curious as well. What did you mean by a clever day?
So in our classrooms, our students are expected to at least come up with 2 different methods for solving a problem. So the method might be that I drew a picture or I used the virtual manipulatives. Another student might say, well, I solved it using a number bond. And so a clever day is when you can think up of another way that just to kind of raise the ceiling a little bit. For my higher level students, sometimes I'll say, can you think of a way that somebody else won't think of? That little girl that you saw the picture of way back here, she brought, it was on the other handout. She brought the picture up to me and said, today is my clever day, because let's see. She said, I could make 6 with 3 parts, and that wasn't part of the task. So for her, here it is, the Google slide. It was her clever day, and she was super proud. So clever day is just something the kids will say, today was my clever day. Here she is. So that was in the classroom. She thought of a way, and then what happens is another kid will go, oh, I didn't know we could use 3 parts. Really, the standard was just saying 2 parts, but I'm not going to stop a student that would want to investigate more. What helps you know physical manipulatives versus virtual tools or pictures? The concept that they're learning. So as I referred to earlier in the presentation, I have kindergarten students right now that are working with 3D shapes, and they're trying to start to add some vocabulary about the attribute of these shapes. That's something they can't do in a virtual environment. They need to be feeling, touching, curved, pointy. So for me, that's a non-negotiable hands-on. Base 10 blocks, my original, like when we're just trading to make 10s, I'll use 10 frames with counters or the base 10 blocks. But when we start to get higher operations with them, then I'm definitely going to use the base 10 virtual more than I do the others. The kindergarten students I'm working with right now love the color tiles. And as a teacher, it's really neat for them to take a picture and get it in a Google Doc, get it in a Jamboard, get it in a Seesaw activity, because if not, they write all over the page. And so the Brainingcamp app has really helped to clean up the workspace. So if I have something where I'm trying to assess them and I want to hear their voice, we'll use a virtual and they'll take a picture and put it on the Seesaw so I can hear their thinking. What can we have students say to themselves when they have to subtract more instead of you can't do that? I always say, is this going to be, I like to use the word friendly. I know it's not a mathematical term, but is it going to be friendly for my brain to subtract 8 if I have 2? And I've had first graders say, yes, that's -6. But typically I'll say, if it's not, what's the best way to think about this number? And I'll build it with the app before I start to even do the math. So if we went to that base 10, I would say, let's look at the task and is this going to be friendly? And one thing I'll say, for example, we're subtracting 28. I might say, all right, let's look at our 10s. Is 20 going to be easy to subtract from 72? And if the answer is yes, then keep it. How about the 2 1s? Are the 2 1s going to be friendly? And your head's going, no, it's not going to be real friendly. Oh, then we might want to rename it. So before we even do any of the recording, we're metacognition. I'm saying it out loud. Is the 7 10s going to be friendly to subtract from? Yes. Are the 2 1s? If yes, keep it. If no, let's rename. Yeah, the text box, Ryan can answer that. I know they've been making some changes on the app that you're going to find out about at some point. I don't know if that's tonight or another night.
That'll be very soon, Sarah.
Okay, very soon. We won't spoil the reveal. Oh, Kelly, thank you. Any other questions that you guys saw? Because again, I get so excited about what I'm doing. I wasn't really looking at the boxes.
Hi, Sarah, it's Mark again. There was one question. I'm thinking maybe while we have a couple of minutes, could you go through the step to generate a share code?
Yes, absolutely. So say, for example, on this screen, I use this for journals as well. So I will take this screen and I'll create a journal prompt. So we typically, we'll record and I'll say, maybe a student makes a mistake and they might, I don't know, just write something like this. I don't even have it out here. And 1, 2, 3, let's duplicate that. All right, we've got 60 and 2. Okay, and we'll hide that eyeball. So I might say one of your friends in class today. So I want this picture because I noticed a student in my class did this and it's not correct or some misconception. As soon as I go over to the left-hand side here where it says share, it's actually capturing just this screen. So if I make changes to the screen later, it's going to always revert to what this screen was when I hit share. So I have 3 options. I can click a link, and that's what I did in the PowerPoint. I gave you the link or code. So here it is. I copy it. I put it in my Google Doc. I put it on my PowerPoint. I put it in my homework, wherever it is. I can share it. Say I want to make it on a journal. I could copy the image and I could come over to a Google Doc or a page. Here was that Google Doc that we were working. And I'm just going to come in here and Control V, and it's going to paste here it is. It's coming up right here. So I can copy and paste. So if I want to make a journal or an exit ticket or something like that, I can copy and paste. And then the last part of that share was the ability to download the image. So again, if you would want to put it on an assessment or somewhere else, you could do that. So very, very cool feature that's new. That's very helpful in sharing virtually, but also in the for teachers, just to save time.
Yeah, thank you, Sarah. When you hit one of the key points, at least for me, if you're creating your own, let's say, tasks or share codes, determine some way to manage those share codes, because those share codes are good for as long as you have a Brainingcamp license. So if you have a school license and you and your colleagues are creating tasks or creating some instruction within the apps, save those share codes so that you can always come back to them as long as you have a Brainingcamp license.
Yeah, and to add to that, Lynn has a question up on the panelist side of things, that if kids have the codes, can they go back in and correct it? Yes, that's the beauty of having that code. And as Sarah said, that it captures that moment. So if you push that number out to a kid that said 62, all those kids can almost do an error analysis of the student's work. They all get that point and they can edit their page individually and not worry about ruining the work of another student's. So yeah, they can easily do that.
So on that document that I shared, I always put the share codes on the document so that if people want to go back later. And for me, if I'm going to spend time in the virtual environment, I've got to have a goal on what I'm assessing. So I've put it with each task what I would be assessing and looking for in creating that and using the Brainingcamp app. Yes, I will share this document again. For some reason, I'm not sure why. it didn't work, but here we go. Anyone, we're going to copy this link and I'll put it in the chat. Other questions you might have. We do little tutorials and presentations all the time. Next week, we have one on fractions. Dr. Yup and myself are going to be working. And almost in every presentation we do, we use Brainingcamps, if possible. So that's really like everybody's hands go up as soon as we start using them. And they're like, what is that you're using? So if you want to see how we use them even more, you can go to our site and see when our events are, and you're going to see them implemented into the learning of different concepts. The site is at methodology.com. That's where you would find information on that.
I also see a lot of people asking a question about how do we add students. I'm going to let Sarah finish up. And when she's done, if you want to stick around for 2 minutes, I will show you how you can add students in Brainingcamp. But
I just want to thank you guys for coming tonight. Again, my information, if you had the handout, it's on the bottom of that handout. And it is also, I'll pull it up here. I'll stick around for a little bit if you have any other questions for me. Whoops. But I just want to thank you again for taking the time, especially many of you had off today. So I really appreciate you coming.
Well, thank you so much, Sarah, for enlightening us and taking the time to show us how to fit that tried and true CRA method into this virtual environment that many of us find ourselves in.
Absolutely.
So thank you. And thank you to everybody who attended. Recording will be posted on our website. And with that, Ryan, if you want to go and I'm gonna stop the recording. And then Ryan, if you want to keep going and show how we can add students, that'd be great.
let it keep recording in case people are seeing it and need to
Got it.
check this
Perfect.
out.
All right.
Okay, so once you sign in, this is the page that you should be seeing. If you want to add your students, and again, the license that you were given or the trial you were given is a 45-day license for you and your students. You come up here to the accounts button. Yours is going to be a little different than mine. You won't be able to add teachers, but you will be able to add students. When you click on students, there'll be an add button. You just follow the directions. All you need to do is make one single generic username and password. Let's do mathology real fast. Make a password for it. Math 1, 2, 3. If yours is unique, it's going to create that classroom. And now every single one of your students uses that username, that password, and they now have access and can do everything that you can do in Brainingcamp. They're going to be able to do it as well. Yeah, it's that simple. So you just have, that's the easiest way to add kids. The last thing I wanted to show you, because someone else was asking this one too, pattern blocks. Down when you go to pattern blocks, they're asking, do you have the quarter and the 12th, or the brown and the purple? Down in the basic, you can change the mat to fractions, and here you have the quarter and the 12th. So if you need those pieces, they're available as well. And that I will stop and hand it back to you.
Awesome. Awesome. Thanks so much, Ryan, for your expertise. And you as well, Sarah. And to everybody who's still with us, thanks so much for everything you're going through during these crazy times. My wife is a special ed teacher, so I understand the challenges that many of you are facing. So appreciate everything that you're doing. And as we let you go tonight, stay safe. And for many of you, stay warm as well. So everybody have a great night. Thank you.
Thank you.
Thank you.